Hi, my name is Dr. Norzaida Abbas and I'm from UTM Razak School of Engineering and Advanced Technology, University Technology, Malaysia. My presentation for today titled Determining the Best Fit Model for Oil Palm Yield and Planted Area in Malaysia. Agriculture sector is full of uncertainties, thus it is important for us to have reliable forecasts on crop yield to provide vital inputs for proper foresight and informed planning, monitoring and predicting changes in crops production. It could also be used to solve procurement issues and propositions of improved crop techniques for higher yield. Hence, this study focuses on mathematical modeling on oil palm production in Malaysia. Why is oil palm being the center of the study? That's because the oil palm industry plays a very important role in our economic development. It is the fourth largest contributor to our gross domestic product, and Malaysia is also one of the main producers of oil palm in the world. Oil palm production occupies the largest agricultural area in Malaysia, and also the industry provides job opportunities and it helps to elevate income in rural areas. That comes to the objective of this study, that is to determine the best mathematical model represent oil palm, and in particular we are going to look at two areas, that is the yield or the production of oil palm and also the total planted area. Forecasting is conducted based on the appropriate model for a 10-year period, and here we use time series approach because it can be used to discover historical pattern that can be exploited in the preparation of forecasts. Since oil palm is a very important crop in Malaysia, there has been many studies on many issues, many issues of oil palm. Here are some examples. Material and methods. In this study, the data, yearly data from 1974 to 2016, and as I said before, we're going to look at oil palm production and oil palm planted area. Time series approach is being adopted. Basically, before we choose or we identified the models that could be used, we did a preliminary investigation, and it was found that these three models are suitable, that is linear trend model, double exponential smoothing model, and the Arima model. So these three models are individually fitted to oil palm production and planted area data to determine which is the best model to present each item. To compare which is the best model, we use mean absolute percentage error and mean absolute deviation. So the model with the lowest value of MAP and MAD will be considered the best model. The first model is the linear trend model. Basically, linear trend model is a special case of regression model in which the independent variable is just the time index variable. The second model is the double exponential smoothing. Exponential smoothing basically use weighted average of past data to make forecasting. So the basic exponential equation is as shown in the slide. We are going to use double exponential smoothing, that is the holds two parameter linear smoothing. This is better to be used when trend is present. So the equation is as given in the slide. The third model to be considered is the auto-regressive integrated moving average, or better known as Arima. Arima models are regression models that use lag values of the dependent variable, auto-regressive and also moving average. And in order to determine the best Arima models, box-Jenkins process is being adopted. Basically, this is the box-Jenkins process. That is, first you plot the time series and you check if the time series is stationary. Then, if it's necessary, then you have to transform it by different things. And then for the model selection, it has to be based on the autocorrelation function and partial autocorrelation function values, and then you estimate the parameter, you check the residual model, and if it's okay, then you do the forecasting. Results and discussion. For total planted area, we fitted 3 models. That is the linear trend model, double exponential model, and Arima model. As you can see, here the value of MAP and MAT for Arima 2 to 3 has the lowest value. Hence, we believe that Arima 2 to 3 is the better model to represent total planted area of palm oil. Here is the graph of the fitted value and the actual data. As you can see, it was very well represented. Okay, based on this result, we do forecasting, and here we forecast for a 10-year period from 2018 to 2027, and the most right column is the percentage of increase according to each year. For oil palm production, only 2 models are being proposed. That is the double exponential smoothing and Arima 011. And again, Arima model 011 is found to be the best model because it has the lowest MAP and MAT value. Hence, the Arima 011 will be used to make forecasting. Here is the fitted value and the historical data. This model has fairly well fit the actual data. So based on this, we did some forecasting for a 10-year period, and here you can see that for 2018 we anticipated a 18.22% increase, and after that the increase is more gradual. Okay, as for the summary, it was found that Arima seems to be the best method to model and forecast. Based on this, we could say that this indicates there is significant autocorrelation between the data for both production of oil palm and also total planted area. It was found that total planted area, we anticipated an increase between 0.14% to 1.98%, and for production, it was predicted that 18.22% increase in 2018 and later a more steady increase until 2027. Although Arima is the best method, but Arima model seems to be more tedious. If you can recall just now, the value of MAP and MAT is not very how can I say, the values are not so much difference between the 3 models. So actually you can also use linear trend and double exponential models because they are as good. But of course, if you want the best, you could use Arima. So it's up to the researcher to think, whether you want to do a more tedious work in order to find the better model, or you can just use linear trend and double exponential model. The forecasted values could be used for better strategic planning with respect to crop production, and it could significantly contribute to developing sustainable agriculture that meets Malaysia's needs. It is proposed that more studies in modelling are needed to ensure that palm oil will meet the export demands for Malaysia to remain as the main world producer. Okay, we would like to thank the following agencies, that is the Department of Statistics Malaysia and Malaysia Palm Oil Board for the data, and also we would like to acknowledge that this study has been funded by vote 15H74. Thank you.